Hello, everybody. Thank you for joining. My name is Tom Danvers from Waygate Technologies. Thank you for joining. So this is a short talk taking you through length measurements on our boroscopes, the real 3D measurement length options. So I'll be taking you through a series of slides, basically overviewing what we can do measurement-wise on our boroscope before talking through very specific use cases associated with length. So a series of slides, and then I'll drop into a sort of a practical demonstration on our boroscope. Okay. So as an overview, really the aim of this conversation and this webinar is to really take you through and enable you to basically interrogate and make use of all of the features that we have on our boroscopes to empower you to basically generate the correct and appropriate measurement for your task. Obviously, it's necessary to make sure that your measurement assessment is done correctly. It's very important, obviously, the decisions that you're making on your boroscope. So, making sure that you're more comfortable with the features that we have on our boroscope. There's a lot there on our MVIQ. And so I felt it necessary to take you through these measurements. So as an objective, the various objectives that we have on this session is to really take you through the various length measurements. We have lengths, point to lines, multi-segments, and we have others as well. I'll take you through. Then we have these other features, what we call surface masks, green surface masks and blue surface masks, talking you through that. And we also have this additional feature called measurement plane, and how that interacts with the various measurements we have depends on which measurement type is active. So again, dropping in a conversation about measurement plane as well into the conversation. So just a few minutes really to take you through this information on this slide. So we have 4 different measurement types on our boroscope: comparison, stereo, then 3D stereo and 3D phase. I kind of normally talk about 3D phase and 3D stereo, but those are measurement types or technologies that's grouped into what we call real 3D measurement. But first off, we have comparison. Really, that's a traditional pixel counting sort of technology where it's necessary to essentially calibrate what you see on your screen associated with a reference sample of a known size. So you're calibrating the number of pixels associated with that feature before you then do a real measurement on your part that you see on your screen. Very kind of, shall we say, low tech. It's not a 3-dimensional, it's a flat 2-dimensional sort of technology where you're really just counting pixels on the screen. So that's not something would normally be used, certainly not if you're using MVIQs or mental flexes from Waygate Technologies, but it is a feature that's available on a boroscope. Then we have what you're perhaps more familiar with is stereo measurement. This is accessible on a wide range of boroscopes that have digital measurement technology. Stereo uses very specific stereo-enabled tips. They're not inspection tips; they're stereo measurement tips, and you can do those various measurements that you see on the chart there. What we call sort of standard measurements, or your lengths, your areas, and your depths, for instance. And then we move to obviously 3D measurement. So this is kind of really a Waygate Technology specific sort of feature. And the big difference is that combine both of those things into that red box that you see is the ability to transmit the image back onto what we call a 3-dimensional point cloud. So that's a really key feature to enable you and empower you to interrogate the scene much more in 3 dimensions so that you can have much greater confidence in the quality of the image that you're capturing, but also the quality and the precision of the cursor locations that you're assigning onto the image. Because the greatest source of error in a measurement is essentially ourselves, in as much that we are tasked with generating the measurement image on our boroscope. And if it's a poor quality image, it's going to be a poor quality measurement. But also the other factor is, from a user's point of view, is that we dictate the position of our cursors. If those cursors are positioned incorrectly, that's obviously going to impact on the measurement output. So as you can see here, through real 3D measurement, there's a lot more measurement types that we have available. And just giving you an overview of the measurement technology here. So we're going to be really just talking about lengths in this talk today. Let's try and go to the next slide. So I'm going to just take you through lengths, point to lines, multi-segment, and depths. Believe it or not, depth is a relevance here in this conversation before moving on to the boroscope. So what you see here is an image I captured. All these images that I'll be showing you are captured from various scenes from within gas turbines over the last few years that I've been working in Waygate Technologies. So some of you might recognize this is a particularly tired looking combustion chamber or liner within the combustion chamber. And I've placed a series of different types of measurements that you see on there. You can see erosion or thermal distress, and obviously missing material associated with erosion, and a crack unzipping sort of towards the distance in the background on this chart. And we see a series of lengths or cursors applied to this image. So what I'll be talking about here really is defining what a length measurement is. A length measurement is essentially the simplest form of assigning a length onto the boroscope. It's a simple two cursor application where you're applying the edge, the beginning and the end, you're assigning two cursors, and a straight line is drawn across the image. Here I've intentionally, and I'll show you on the boroscope, this is intentionally a flat or very, it's not a curved surface. So this is a liner in a combustion chamber. So essentially quite flat across the distance that I've applied these two cursors. And that suits length measurement very, very well. If this was a curved surface, you'll see in other examples, lengths might not be the most appropriate choice to opt for. You can see, because I've activated the length measurement, you can see next to the text box that says A, there's a little straight line icon. So that's our length icon. So that's telling me that I've activated my cursors associated with the length measurement. And you can see blue lines, these blue surface masks. So I'll be talking about those more when I move to the practical side of this talk. But those blue masks are really helping you understand the relationship and the angles of your line that you've assigned between those 2 points on the cursor. And yes, measurement plane applies to all of these things that I'll be talking to you about as well. So that's a length measurement, just as a quick opener or introduction. Let's next slide. So here we have a typical defect, what might look like a nick, but it's actually slightly different when we move into the three-dimensional space. But you might appreciate this is a compressor blade within a gas turbine. So a point-to-line measurement. Again, it's a length measurement. But importantly, this is a length measurement that is extrapolated perpendicular from a reference line. The reference line is represented as a dashed or dotted line that you see on the right-hand side, or the leading edge of this compressor blade. So it's a fixed point upon which a length is measured from that point. So what you can see in this chart, you might pick out on the icons. Again, I've got a length applied. That length measurement is measuring at 17 millimeters, whereas the length for the point to line, which is the B, is 1.7 millimeters, so a tenth of what you see on the length measurement. And that will become very apparent when we look at it live on the boroscope. You can see on the cursors applied to the screen, the length, one of the length cursors is applied to perhaps, well, it is applied to essentially the surface in the background. So what looks like a short distance traveled on the two-dimensional screen is a very long distance, because you can tell from the measurement result it's 17 millimeters. So point to lines are very common, probably the most common measurement that you would use on your boroscope when you're performing gas turbine inspections, in terms of interrogating the depth or the length of features that are edge breaking features, if I call them that, the typical nicks and dents, and indeed sometimes cracks that emanate from the edges or tips of blades, for instance. But yes, pointer lines can be used in all sorts of other applications as well, as you can see on the right-hand side. So, kind of the widths of welds, the widths of all sorts of surfaces and the gaps. In this case, I haven't activated one of the cursors, so you don't see the blue mask. So the blue mask does apply to pointer lines as well, and so do measurement planes. So we'll be talking through that a little bit more in the next few minutes. Here's another sort of shot of a particularly nasty looking crack on the leading edge of a nozzle guide vane. And so this is, okay, it might not look it on this two-dimensional screen, on this flat surface. This is a very curved surface. So these are typically or situations where you would choose to perhaps use multi-segment. Ideal for not just tracking the surface emergent length of a crack that might be passing through different lengths or different corners. You can do a straight length with a multi-segment, but every time you place your cursor onto the screen, you're forcing the measurement to be applied across that screen. So what you can see on the blue side, on the blue active cursors, multiple cursors dropped along the length of this crack. And you can see subtly the difference between 11 millimeters and 12.6 millimeters between these two lengths. So a simple length on A and a multi-segment on B, as you can tell by these icons. Multi-segment is also another, does have a kind of a semi-hidden feature of being also able to measure angles. And I'll take you through an example where that is possible using the multi-segment feature. And as you can tell, the requirement to, well, if there is a requirement, but here there's a requirement to place multiple cursors onto the screen. It's possible once that's completed, and if I change my mind and I wanted to add another few cursors here and there, then that's possible by pressing down on one of the cursors, and a new cursor is added in the previous sort of position, and I can take you through that. And for very complex shapes, similar to areas that I'm not talking about here, but you can apply up to 24 cursors to generate a multi-segment measurement. So that's length, point to line, multi-segment, and here we're moving on to depths. So here I've captured an image. So this, unlike some of all of the other images that I just showed you, was a full field image of 3D phase measurement. This is an image captured from one of our 3D stereotypes, and I can tell that because it says that it's got a character, the plus character, next to the tip serial number, which says LQ0. The little plus tells me, and will tell you and anyone that's using it, that this is not a traditional stereo, this is a 3D stereo image. And the other giveaway sign is that we have a 3D point cloud represented on the right-hand side. So very much unlike traditional stereo, this 3D stereo image provides you with that useful representation of the point cloud. Again, I'll take you through this. So what you see here is a turbine tip at the bottom of the screen. And here we're looking at determining the distance between the tip of a turbine blade and the corresponding seal segment surface, which is a static part that is designed to rub and sacrificially rub it to allow sort of efficient operation, in this case of the turbine. So I've dropped cursors here that are kind of similar in size. Again, you might recognize B is length because of the simple line icon, and A in this case represents depth. So depth is clearly a different word to length, but the reason why I'm talking about depth, and I kind of want to spend a bit of time talking about it, is because similar to point to line is point to a two-dimensional line. Depth is essentially a point to a three-dimensional plane. So it's still a length measurement in the context of this conversation. So this is the length between the tip of a blade and the corresponding sort of plane associated with the seal segment, for instance. So it could be called point to plane or point to surface. So it's important to think of depth in that regard as well. So it's a very useful feature to essentially measure the distance between two parts. In this case, these are a short gap between an abradable seal segment and a turbine blade, and the importance of applying a plane rather than just a simple length measurement that will come through when we interrogate the three-dimensional point cloud. So I've whizzed through that fairly quickly because I wanted to spend most of my time talking through how it's done on the Borescope. And once I've done that on the Borescope, we've got time for questions and we'll summarize and hopefully we'll have come up with time. But I've already taken 15 minutes. So let me stop and share my Borescope screen. Okay, so what you see is my Borescope. So I've got some saved images showing you some of the examples that I told you about earlier or showed you about earlier, and some additional ones as well, while stressing the fact that we can use things like making particular attention to the blue surface mask and the measurement plane as well. So I've loaded up that image that you saw earlier from the combustion chamber, and I'll just pick up the line. And what you see, it's kind of snapped to this again is a three-dimensional phase measurement, a 3D phase measurement image. But what I'm seeing is the traditional 2D view on the left-hand side and my point cloud representation on the right-hand side. So as I'm placing cursors on my component, I can zoom in and interrogate that as I'm going through the process of measuring. So here I've just selected a length measurement, and I'm just going to drop a point up here. So I just perhaps want to just measure the axial length of this crack, even though it's kind of unzipping in different directions. And I just wanted to if I just enter that and go into my two-dimensional, just to show it on full view and activate a cursor, you can see these blue lines, these blue surface masks. So if I chose to do a length measurement along here, it's important that I don't want to create a diagonal and sort of a longer image than is otherwise necessary. So really this is suited, you can tell perhaps that this is best suited with a point to line. But if I wanted to use line, then really make use of these blue surface mask lines so that the edges, if I now move to my full image, point cloud, you can see my edges of my blue mask lines line up with the edge of my combustor bay, and those lines will always be perpendicular to my cursors. So as I move my cursors, which I can do in the point cloud as well as the 2D, you can see. So I'm now looking at the blue line at the bottom of this screen to make sure it lines up with the edge of the combustor bay. So that's quickly. So I can apply up to 5 measurements on any one image. So I don't really need to delete that image. I can go to now multi-segment, for instance, without deleting the length. And as I've selected that length, you move the cursor, press enter. Every time you press enter, you're assigning a point onto the surface. And because it's quite, I can pause and just zoom in, make sure I'm happy with what I'm applying. So I've kind of actually passed through where I need to be. So I can just drop a point here, move across. Very quickly be able to sort of determine the surface emergent length of this crack. Let's just move that so I can get up here. Oops. Okay, oops. Let's drop it down. And then once I've pressed done, it'll just show me the point cloud representation of that one measurement that I've done, in this case, the multi-segment. So as you can see, length measurement, 28 millimeters on the right hand side, and my multi-segment is approximately 2 millimeters longer because obviously I've traversed the actual gas path, the path of the crack. So multi-segment, very useful for not just flat surfaces but curved surfaces, but applying multiple cursors so that you can determine the full surface emergent length if you need to. Okay. Here's an image taken from a HP turbine blade. you can see straight away there's a crack. And it's a very simple example. I'm just applying a cursors associated with the edge here of the. It's emanating from one of these sort of wear indication marks. Again, I'm kind of paying close attention to these blue surface masks that I do want to make sure they're running parallel. If I choose to do length, then it's necessary that I'm not generating a longer measurement than otherwise needs to be. So a very simple length measurement there. Always, and I always say this all the time, so forgive me for always repeating myself. Always check your point cloud. Always check and that's talking about the quality of the point cloud, but also obviously checking it in terms of making sure your cursors are placed in the right position. So another crack. I won't go through this. I'm conscious of time is passing on very quickly, so that's really mainly best for a point to line measurement. So here's an interesting one. So what looks like perhaps people might be thinking this is a nick. Obviously, during the live inspection, you'll be able to determine what that defect is before you start measuring it. But here's obviously a captured image that you wouldn't have seen before. And here I'm just quickly taking a datum point along the edge of the blade. It compensates for the optical distortion, so the line isn't truly straight. It's compensating for the optical distortion and still hugging the edge of that blade. I'm now going to drop my third cursor, which essentially is my length measurement emanating from that reference point. Again, with the point cloud, you can quickly see that this is really not a nick. This is a dent causing quite gross deflection. And in that orientation, it looks like a nick or missing material, but you drop the plane or rotate the plane, and you can quickly see that the plane of my measurement that's represented by the blue box is clearly not lined up with the plane of the aerofoil. There's much more deflection still there. So the edge of the defect is really as you move your third cursor point and your plane is aligning with the aerofoil plane, you realize that the true depth of the defect is somewhere close to where I've got my active cursor, sort of around the 2.8 sort of millimeter mark. Another little this is probably something where I'll just drop in the content associated with measurement plane. So if I drop a measurement plane on here, so this is basically going to show you the amount of deflection associated with this defect. So measurement planes, and as you can see with the green mask, basically that is a feature that we have on both 3D stereo and 3D phase. So both types of measurement that falls within this term of real 3D measurement, where we're able to kind of force points to sit on what we call the measurement plane. And I'm really showing it here because it's actually the useful feature associated with it in this case is actually the surfaces that agree with those 3 points, plus or minus a very small amount, are all flooded with green, the green surface mask. So that's good. That's what we expect. And you can see the amount of deflection that doesn't agree with the measurement plane because it's no longer green. So you can kind of see the extent of the deflection by using measurement plane. So it's kind of an interesting aspect of using measurement plane in this case, because it can kind of show you which surfaces are not deflected. In other words, highlight the areas that are deflected in a component such as this that has got a large dent. Let's come back out of here. A lot more to go through. The clue here, so you can see the plus sign on the right hand side. So we've got a 3D stereo tip here. If I activate measurement, so typically as you might have gathered by now, and hopefully perhaps in your normal use of work, you'd be assigning not a length measurement but a point to line measurement. Quickly able to sort of drop 3 points on the edge of there. Checking my point cloud. Always check your point cloud. Always. Here's an example where I might choose to apply a measurement plane. especially if let's just force my cursors and they'll made them slightly diagonal. So the measurement plane represented by the blue box doesn't align with the blade. So if I add a measurement plane to it, it'll force my points to now drop onto the measurement plane. So it's now a flat surface. So we've got to take care with this because you can, if you wanted to, is force the measurement out, and obviously you don't want to force it out into space essentially, and make that measurement much longer than it necessarily is. But using measurement plane in conjunction with, in this case, point to line, is a very useful feature to make sure that your measurement, represented by the pink line on your screen, which is 0.93 millimeters, is aligning to the plane of the component, in this case the aerofoil. So it's a very useful feature. Make sure you're checking the point cloud all the time, and certainly when you're using measurement plane, make sure your cursors aren't too far off. Well, they don't want to be off the blade at all. So yes, by all means, please make use of measurement plane when you're doing point to line measurements. So here's that curved surface again associated with the LP NGV. Here I'm going to drop in a multi-segment. Just quickly assign 3 points, and by quickly moving around and spinning my component around, my point cloud around, you can see quickly it's a curved plane. And you can tell I need to really apply more points to make sure. Oh gosh, let's just undo that. There we go. I've applied too many points. Thankfully, you can keep pressing undo. Move it around, so it's a very useful feature. So I'm going to just quickly show you very roughly, because we're kind of low on time, but using multi-segment is a very useful way of determining surface emergent length using multi-segment. So please use that on curved surfaces, unlike point to line or length, because point to line or length will just give you a length from start to finish without hugging the surface, unlike multi-segment. So just moving, let's just show you I wanted to show you this this feature associated with multi-segment where we have angle. Just going to be quick. So this is an example of tip curl. I've applied 3 cursor points. If I apply 2 cursor points or 4 or more cursor points, you will not get an angle. But by using 3 cursor points, and obviously checking with your point cloud, you're able to determine not just the length of that multi-segment, but also the angle. So if I subtract 180 degrees from 123, you've got a deflection of approximately 57 degrees in this case of the tip. So yeah, be aware of the angle feature that we have on multi-segment. Oops, let's just show you some depth. So apologies, we're already at 29 minutes, so I'm going to just be quickly with depth. So here I'm moving towards depth. I'm going to drop a reference plane. That's 3 points. And with depth assist, it will snap to the greatest distance immediately above that plane. So I didn't apply the 4th point, but I can move it if I want to by jogging it around, and I can make it snap back to depth assist by just holding it down, and it snaps back. So this is essentially a point to surface measurement, a very useful feature. Again, just check your point cloud. If you were to use measurement plane for this, for depth, measurement plane is going to force your 4th cursor to the measurement plane. So if I applied a measurement plane on top of my 3 points, that will turn my measurement into 0. So you've got to be aware that measurement plane, sometimes it helps you, sometimes it doesn't. In this case, it's not something that's required, because you can tell everything on my honeycomb liner is in agreement because of the green mask. And quickly, with depth, it's not immediately obvious, but a really useful feature to determine, okay, not length, but in this case, diameter. So diameter of a tube. So again, drop 3 points, very narrow points, and with depth assist, it will snap to the maximum distance from that plane. So I've got, within a couple of seconds, I've determined the diameter of this tube. If I want to just check that measurement, maybe just draw another. So I'm determining, the diameter of this is approximately 16 millimeters in diameter. Again, you can kind of show that on the chart here. So length measurements, there's lots that we can do. Just make use of all of the different features. Lengths in the basic lengths are very, should we say, dangerous to use if you're not checking the point cloud. It's very easy to generate diagonals and false images, false measurements. Let me just take you back to my slide here. So a quick demonstration. I'm just slightly over time, so apologies for that. But in summary, I'm just taking you through those 4 measurement types. It's not actually 3. So I've included depth intentionally because it is a point to surface measurement. So make sure you're using the right measurement type for your application. Always, it's always important to check the quality of your point cloud, whether you're using a 3D stereo or a 3D phase measurement. Get nice and close as you can. It depends on your tip that you have fitted, because you've got different ranges for different tips. You can check for noise by checking the bumpiness in your surface, because every time you assign a cursor, you're assigning a cursor to that point cloud. So a nice, smooth, low noise surface is going to generate a really good quality measurement for you. So we've talked through the surface mask, but also the green surface mask, reference plane mask, and the measurement plane. So use the measurement plane as well to really help you get high quality aligned measurements where applicable, not all the time. The zoom window is excellent. The little round zoom window that takes you up, I think it's 3 times magnification. So make use of that. Use the joystick, the touch screen, but also the little 4 cursor points on the zoom window to really get yourself precise positions. And yes, there's lots more information that we have on the measurement handbook. So there's a link. I know it's a very long link, but this session is going to be recorded and saved on our YouTube channel. So, or you can take a screenshot now, but that's a link to our website that takes you through to the MVIQ website. And there's lots of materials you can download there from the website. The important one in this context is the measurement handbook. So if you click the selection for handbook, and it will give you the measurement handbook to download rapidly. Lots more information there. So hopefully that was all very useful. Sorry for going over time by a few minutes. Yes, if you've got any questions, now's a good time to put it into the chat. Otherwise, thank you very much.